Assalamualaikum and hi everyone. Right, today we are going to learn new topic that is chapter 2. There are 4 subtopics under chapter 2, Thermochemistry. 2.1, Concept of Enthalpy. 2.2, Calorimetry. 2.3, Hess's Law. 2.4, Born-Haber Cycle. The first part of thermochemistry is about 2.1 concepts of enthalpy. Right, so what you are going to learn today, first explain endothermic and exothermic reactions using the complete energy profile diagrams, state standard conditions of reaction, and define the following terms: enthalpy and standard enthalpy. Define and write thermochemical equation for each of the following enthalpies: formation, combustion, atomization, neutralization, hydration, solution, or dissolution. Before we start, let us look at the important terms that we usually use during this lesson. First is about the surrounding. Surrounding can be defined as everything that lies outside the system. For example, like air, and the flask. System is any specific part of the universe. For example, like bubble of gas and the solution inside the flask. Heat can be defined as energy transferred between two bodies of different temperatures. The heat can be transferred either heat out of system to the surrounding or heat moved into system from the surrounding. Thermochemistry is a study of heat change in chemical reaction. It usually occurs two kinds of reaction, that is exothermic reaction and endothermic reaction. In exothermic reaction, heat is released from the system to the surrounding, whereas for endothermic reaction, heat is absorbed by the system from the surrounding. Let us consider for the following process. So can you guess which process is referred to the endothermic reaction and which process is exothermic reaction? First you are providing the ignition spark for the gas to flame up. So this is an exothermic process. As the gas is heated, it is burning and giving you heat. This is also exothermic process. Energy from the pan is absorbed to cook the egg in. So this is endothermic reaction. Conduction occurs when two objects at different temperatures are in contact with each other. Heat flows from the warmer to the cooler object until they are both at the same temperature. The iron and the cotton shirt is in contact with each other, so there is conduction between them. Energy transformation, while ironing clothes, take out their wrinkles and make them smooth. In the previous lesson, we already learned the meaning by heat, that is, energy transfer between two bodies of different temperatures. So, this makes the heat which is a type of energy. In the iron, electrical energy is used and it is transformed into heat energy. So what is the meaning by energy? So energy can be defined as the ability to do work. The unit of energy is in SI unit, that is in joule, where 1 joule is equals to 1 kilogram meter squared per second squared. Other unit that usually used is calorie, where 1 calorie is equals to 4.184 joule. In exothermic reaction, the value of delta H is negative. So this is because the enthalpy of the product is smaller than the enthalpy of the reactant. Heat is released from the system to the surrounding. So for example, like combustion and neutralization. Let us consider for the following reaction. Reaction between A and B produce C and D, where the value of delta H is negative value. So we'll get this energy profile diagram. So the y-axis you can label as enthalpy or potential energy. For the x-axis you can label reaction progress or reaction path. So when we draw the energy profile diagram, the enthalpy of the reactant is bigger than enthalpy of the products. So that's why the differences in energy, which refer to delta H, is equal to negative value. In endothermic reaction, the value of delta H is positive. This is because the enthalpy of the product is bigger than enthalpy of the reactants. Therefore, the heat is absorbed by the system from the surrounding. For example, like ice melting. Consider for the following reaction, we have A and B as the reactants, and C and D is the product, and the value of delta H is positive. So this is the energy profile diagram for endothermic reaction. So you can label the y-axis as enthalpy or potential energy. For the x-axis, you can label either reaction progress or reaction pathway. Since the enthalpy of the product is bigger than the enthalpy of the reactants, therefore the value of delta H is positive value. There are two words that are usually used in the lesson, that is enthalpy, or we can symbolize it as capital H. Enthalpy is the heat content or total energy in the system, so it is commonly measured through heat change. For example, like system undergoes combustion or ionization. So second is about enthalpy change, or we can symbolize it as delta H. Okay, enthalpy change is referred to the heat given off or absorbed during a reaction at constant pressure. Okay, for example, in exothermic process, the enthalpy of the product is smaller than enthalpy of the reactant. So therefore, the value of delta H is smaller than 0, negative value. So which means the heat is released. In endothermic process, the enthalpy of the product is bigger than enthalpy of the reactant. So therefore, the value of delta H is greater than 0, positive value, where heat is absorbed. Next, we have to know the differences between enthalpy of reaction. So that is delta H, and standard enthalpy, that is delta H naught. So enthalpy of reaction can be defined as the enthalpy of heat change associated with a chemical reaction is equal to enthalpies of products minus the enthalpies of the reactants. So we will have this formula. So delta H reaction is referred to the sum of the enthalpy of the product minus sum of the enthalpy of the reactant. Whereas for the standard enthalpy, or we can symbolize as delta H naught, is referred to the enthalpy change for a particular reaction that occurs at standard state, that is 180 M, 25 degree Celsius, or 298 Kelvin. So there are 6 types of enthalpies that you should know. First is enthalpy of formation, enthalpy of combustion, enthalpy of atomization, enthalpy of neutralization, enthalpy of hydration, and enthalpy of solution, or also known as dissolution. The enthalpy of formation, we can symbolize it as delta HF. F is stand for the formation. So it can be defined, the heat change. Heat change here, it can be heat absorbed or heat release, endothermic or exothermic reaction. When 1 mole of a compound is formed from its elements in their most stable state at stated temperature or pressure. So you have to remember this definition. For example, okay, formation of 1 mole of liquid water. Okay, so it should come from its element, that is hydrogen and oxygen. So the stable state for hydrogen is in gas. Stable state for oxygen is also in gas. So since the product side should be 1 mole, so therefore you have to balance at the reactant side. And the value of delta HF is negative 286 kJ per mole. So second example, formation of 1 mole KBr that exists in solids. So KBr is one of the example of a salt. Okay, so it should come from its element, that is potassium, that exists in solid, and bromine. So bromine Br2 that exists in liquid. So the product should be 1 mole. So therefore you have to balance at the reactant side. The value of delta HF is negative 392 kJ per mole. Okay, so the standard enthalpy of formation of any element in its most stable state form is 0. So you have to refer that standard enthalpy of formation. The condition should be temperature 298 Kelvin and pressure 1 atm. For example, like oxygen gas, okay, standard enthalpy of formation for oxygen gas is equal to 0. Standard enthalpy formation of chlorine gas is also 0. Okay, so what is the meaning by the standard enthalpy of formation? Delta H naught F. So when we add standard in front of the word enthalpy of formation, so what is the difference? So the difference here is refer to the condition. So for the standard enthalpy of formation, so the reaction occur at standard temperature and pressure, that is 298 Kelvin and 1 atm. So in the thermochemical equation, so you have to write delta H naught F, which refer to the standard enthalpy of formation. Enthalpy of combustion, delta Hc, can be defined as the heat release, which means it involves exothermic reaction, when 1 mole of substance is burned completely in excess of oxygen at stated temperature and pressure. For example, combustion of methane gas, okay, in excess of oxygen, it will produce carbon dioxide and water. Okay, so 1 mole of substance here is refer to the methane, refer to the reactant. Reactant should remain 1 mole. So therefore, to balance the equation, you have to balance the other species. The value of delta Hc is negative 802.3 kilojoule per mole. Right, so next, enthalpy of atomization, delta Ha, can be defined as the heat absorbed. So which means it involves endothermic reaction, when 1 mole of gaseous atoms is formed from its element in their most stable state at stated temperature and pressure. So delta Ha is always positive because it involves only breaking of bond. Okay, for example, formation of 1 mole of gaseous sodium atom, it should come from its element, that is sodium. The most stable state for sodium is in solid. So 1 mole here should be at the product side, 1 mole. Okay. Second example, 1 mole of gaseous chlorine atom. Okay, formation of 1 mole of gaseous chlorine atom, it should come from its element, chlorine. So chlorine exists in gas, Cl2 exists in gas. To balance the equation, so the product side should be 1 mole. So therefore, you have to balance at the reactant side. So this is the value of the delta Ha. Unit should be in kilojoule per mole. Alright, so if the question asks standard enthalpy of combustion or standard enthalpy of atomization, so you have to change the word from stated into standard. The definition should be ended at standard temperature and pressure. Okay, we move to the other 3 type of enthalpies. So enthalpy of neutralization. So the symbol here is delta Hn. N stands for neutralization. So it can be defined as the heat release. So which means it involves exothermic reaction, when 1 mole of water, H2O, is formed from the neutralization of acid and base at stated temperature and pressure. So 1 mole of water here is referred to the product side, should be 1 mole. So therefore, when you want to balance the equation, so you have to balance to the other species. Okay. So the value of delta Hn is equals to negative 58 kilojoule per mole. So usually for the neutralization between strong acid and strong base, produce salt and water, the value of delta Hn is approximately to negative 58 kilojoule per mole. Okay, enthalpy of hydration. So here is the symbol. HYD is referred to the hydration. So it can be defined as the heat release, so which involves exothermic reaction, when 1 mole of gaseous ion is hydrated in water at stated temperature and pressure. So for 1 mole of gaseous ion here is referred to the reactant side. Okay, reactant side. should be 1 mole gaseous ion. When hydrated in water, it will convert into aqueous ion. Okay, the value of delta H hydration is negative 406 kilojoule per mole. Okay, enthalpy of solution. So here is the symbol SOLN. It stands for solution. So it can be defined that the heat change. So heat change here, remember, it can be exothermic, it can be endothermic. So meaning that involve heat absorb or heat release. Okay, when 1 mole of substance is dissolved in water, okay, to form a very dilute solution at stated temperature and pressure. So 1 mole of substance here is referred to the reactant site. Reactant site should be 1 mole. For example, KCl that exists in solid, since it is a kind of salt. When dissolved in water, it will dissociate and form K plus aqueous and Cl minus aqueous. So this one, the reactant site should be remain 1 mole. So you have to balance at the product side. Okay. So the value of delta H solution is positive 690 kilojoule per mole. Alright, so remember, you have to memorize all the definition for all 6 type of enthalpies. And when the question asks about standard, let's say standard enthalpy of neutralization or standard enthalpy of hydration or standard enthalpy of solution, just change the word from stated into standard. So your definition should be ended with at standard temperature and pressure for the standard enthalpy of reaction. Okay, thermochemical equation shows the enthalpy change. So it involves an equation written on the left side and the value of delta H written on the right side. So it should have this both combination equation and also the value of delta H. This is referred to thermochemical equation. So what are the information that we can get from this thermochemical equation? So from here, 1 mole of liquid water is formed from 1 mole of solid water, that is ice. It absorbs 6.01 kilojoule per mole of heat at 0 degree of Celsius. Okay, when 1 mole of H2O solid, that is ice, is formed from 1 mole of liquid water, the magnitude of delta H remains the same, which means the value of delta H is the same, however, with opposite side of it. For example, like this, okay, from H2O liquid, okay, and it will produce ice. So the equation is reversed. So the sign is changed from positive, now become negative. However, the magnitude, the value is remain the same. Okay. However, when 2 mole of H2O solid, that is referred to ice, 2 mole of ice is formed from 2 mole of H2O liquid, the magnitude of delta H also change. For example, like this. Okay, so therefore, when the stoichiometric coefficient for the equation changes, so the value of delta H also changes, times 2. Right, so example number 1. So the combustion of a sample of aluminium produces 0.25 mole of aluminium oxide and releases 419 kilojoule of heat at standard condition. So here is the equation. Calculate the standard enthalpy of combustion of aluminium. First, we refer to the equation. So equation here is already represent the enthalpy of combustion of aluminium. Alright, and the clue given here is 0.25 mole of aluminium oxide released for 19 kilojoule. So to calculate the heat release for this reaction, so you can use mole relation. Okay, so you have to write this mole relation. So 0.25 mole Al2O3, okay, released for 19 kilojoule of heat. So if 0.5 mole of A2O3, so it will release, okay, so you can write like this. So it will release 838 kilojoule. So when we solve by using mole relation, and therefore we'll get the value here is positive value, right? So therefore you have to write the conclusion. So as we know that enthalpy of combustion involve heat release. So you write it again, the conclusion. Delta H naught for combustion of aluminium is negative 838 kilojoule per mole. So unit here should be kilojoule per mole as because question asks about standard enthalpy combustion. So it's referring to the combustion of 1 mole of aluminium. Okay. So please note that the standard enthalpy of combustion of aluminium is involve heat release when 1 mole of aluminium is completely burned in excess of oxygen at standard temperature and pressure. Remember, temperature should be 298 Kelvin, pressure should be 1 atm. Okay. Okay, for question B, so determine the enthalpy of formation of aluminium oxide and write its thermochemical equation. Right, so from the previous calculation, we already calculate the intended enthalpy combustion of aluminium. And here is the thermochemical equation. Right, so first you have to write the thermochemical equation for the enthalpy of formation. So remember, from the definition of enthalpy of formation, so 1 mole is referred to the product side. Okay, so 1 mole of Al2 produced from its element at their stable state. So for example, like aluminium, okay, aluminium, stable state for aluminium is solid and stable state for oxygen is O2 gas, and the product side should be 1 mole. So therefore, you have to balance at the right-hand side and become like this. So we want to find out the value of delta H naught F. So when we compare both thermochemical equation, we notice that half or 0.5 mole of aluminium oxide, it will release negative 838 kilojoule per mole. So for the enthalpy of the formation, we want to find out formation of 1 mole of aluminium oxide. So therefore, you just times 2 delta H naught C in the previous calculation times 2. So we will get the standard enthalpy of formation of aluminium oxide is negative 1.68 times 10 power 3 kilojoule per mole. Okay, so remember this definition. Okay, so this is the thermochemical equation. So you have to include the balance equation and also the value of delta H naught F.